All right, so just a very quick recap. Okay, this is what we had last time. So we were building a very simple rock, paper, scissors Python program that you play with the computer player. So our job is to write algorithm for the computer player so that it can play with human being. And obviously we want to have a really good strategies. Right now, strategy is very simple, and we just do the random choice from 1 to 3. And then, so if we start a random program, and here you can do the choices, the human player do the choices, and then it's basically totally random, okay? So the computer choose, yeah, everything. It's a lot of threes. Yeah, also had to choose. Okay, so basic is random. All right, but what we want to use machine learning to try to learn the human players' choices. Basically, learn from this to see if there are any patterns. As I showed you, if I keep doing 1 1 3, 1 1 3, 1 1 3, and then we hope the computer can actually pick out that pattern so that it can predict I'm going to do the 1 1 3, and then it will always be winning. All right, so last time I already told you that this is actually a very simple classification problem. Okay, so you're trying to predict what's the next choice from the human being, but then you do the prediction based on his or her previous choice. It could be just one choice, or maybe it's better to just look at the past 2 rounds, just in case there's some, more clear patterns. Okay, so this is where we were last time. Okay, think about this is the table we already built. This is a target column, and these are the input features. Okay. So if you want to just form a pattern like this, I already showed you. Assume that the players are doing things like 1 1 3, 1 1 3 like this, and then you should be able to turn that sequence into this table, and then you should be able to use machine learning to train the model. Okay, so let's do this. I'm not going to do anything with the game, but let's just go back here to put input data and then output data there. Okay. So for the input data, going back here, so I'll just follow this one. It's 1 1 3. So I'll just do the input data first. 1 1 1 3 3 1 1 1. Right. So we'll do this one here. 1 1. Okay. So it's 1 3 3 1. 1 3 and 3 1. So 4 of them. Okay. For the output data, and it's gonna be 3 1 1 3. 3 1 1 3. All right. So we're doing the same thing. Okay, classification with sklearn. So getting the input data, output data ready. And then we're going to start to run the training process. So last time I showed you a very famous one. It's called SVM. All right, so with that, you can do a model, which is SVM, SVC. All right, and then we do the typical training process. Also with the same input and output data. All right. So once that is finished, now you could try to predict. Okay. So predict often you give you follow the same kind of input data format. So for example, I'm gonna do this time I see you do 1 1 again. All right. So in that case, we're supposed to see a 3 out of it, right? So let's see if the code works. So rerun everything. All right, as you can see, the very first here line prints out the test results, right? So we print 1, 1, and it's going to give us 3. Okay, there very clearly in the input data, we already seen that kind of pattern. Okay, 1, 1, 3, 1, 1, 3. And yeah, that kind of proves that this model here already works. Okay, now, if you understand this, all we are trying to do right now is to use this one to guide our choice. Okay, so if we know what the human is trying to has shown in the past 2 games, then we should be able to try to predict what he or she is going to do next. Okay, so let's actually start to modify the code a little bit. So what I'm going to do is I'm going to put this code right here. Okay, so I'll just predicting the human player's next choice, right? So let me move this one into a variable. Player choice, next choice. Okay, because this one print out a list, so I'm going to grab the very first item out of the list. So I'll do this one, and then just for us to debug, so we are printing the result here. Okay, and then based on this next choice, then you can do your choice, right? So if you think player you're going to do 3, and then you will need to choose 1. If you predict they're going to do 2, and then obviously you're going to do 3, right? So that you can win it. Okay? So then I would just need an if statement. If the player next choice equal to 1, okay, and then I'm going to return. If it's a 1, we are going to return 2. Okay. If the next choice will be 2, we should return 3. Otherwise, we'll return 1. Okay, that's how we can win it. Okay, so this time the strategy is actually based on machine learning. Okay, so if we've seen this one before, and let's try to run this again. All right. All right, so this time it doesn't matter what I do because I kind of already learned this one with a very little small data set. So if I start to do, oh wait, sorry, no, this is bad. This one is just to do a 1, 1, right? So it's actually a fixed answer. But anyway, so that means it doesn't matter what I do, it always trying to predict the next choice will be 3, so the computer will choose 1. Okay, so it just one more step, right, to kind of move the machine learning model into the prediction. But right now, this line here, okay, this line doesn't make any sense because you always predict based on the past 2 moves, which is 1 and 1. You're not really capturing it, right? So that's why in this program, it's very important that you start to capture all the history. All right, so we'll have another list called a player choice history. Yes, David. So that thing here, 0, okay, because I showed you the prediction here, okay, that shows you a list as a result. It's a list. So that's why if you want to grab that number, you will need to do the first element. Okay, let me show you where that is. This one here. Okay, so if you don't do the first element, this prediction give you a list. Okay, so that 0 simply is just trying to give you the first element. 29, yeah, you're right. Yeah, thanks for pointing it out. Okay. All right, yeah. Very good, guys. Okay, thanks for all the, debug help. All right, so, but anyway, back here, we now need to track all the history because without that, we cannot really make the predictions. Okay, so how do we know the history? Because every game, you're gonna see what the player is gonna choose so that you have the history. So after every game, okay, once you see the results, you are supposed to record clear choice. Remember, you need to do it at the end. Okay, you can't do it right after because you're cheating. Okay, because you won't know that results until all the games are finished, right? So you should put it at the very end. Okay, so is something wrong here? Why is it complaining? Append. Okay, all right, now we're good. Okay, so this way, that history list always contains a lot of choices. All right, so with that, then when you try to predict right here, okay, you can always grab the last two elements from the list. Okay. All right, so the last two, okay, the last one should be this, right? How do we write the second to the last one? Do they want to know something like this? Could anyone give me some help? So if I want to grab the last item, I think it's -1, right? And then if I do the second to the last, is that one correct?
Yes, that's correct.
Awesome. All right, thanks so much. Okay, so and so let's do this one. So this one we grab the last two records and then put that into the prediction. Yeah, it looks right. And then we're gonna get a next choice. Okay. But in the beginning, this one is gonna be empty, right? So maybe we'll just do something like again here, we'll just do a safe check. Okay, so maybe yeah, we'll do something like if clear voice history is less than 3. Actually, no, less than 2. Okay. And then, okay, or maybe greater than 1. So you have at least 2 choices. Then you can do this. All right. So otherwise, I'll still keep it random. Okay. But this one only happened in the very beginning. We just want to have a very clear history. All right. So now by doing this, as you play the game, you are actually adding all the history to the list. Because based on the history, you could then use that to make a prediction for the next one. Okay, that's what's going on here. All right. So now let's try this. If I'm going to do 113 again, because that's how the model has been learned. The model only knows 1 1 3 3 1, right? So especially 1 1. So in the beginning, if I do 1 1, so they're always predicting to be 2. That doesn't make sense because it's just random. Okay, because you don't have enough history. But then if I start to keep doing 1 again, all right. So now this time I do 1, it should be making a prediction, which is 3. And that way the computer chooses 1. Oh wait, why is choose 1? That's not right. So it's predicting that to be 3. So 3 decisions, and we are giving 1. That is correct. But oh, maybe it's probably let me think about this because we probably are like 1 step behind, right? So this is making the right prediction, the right choice. The next choice will be 3. Okay, so oh yeah, sorry, my bad. So as I'm testing this one, okay, I gotta follow that pattern. If I want to prove that, I gotta follow the pattern 1 1 3. I can't do the keep doing the 1, okay, because they're supposed to see a 3 there, right? So So let's actually start doing this. Okay, so I'm gonna, if I do 3 and then I lose, right? And I do 1, 1, 3. So that's the part I'm gonna lose. Okay, 1, 1, 3. Because once they see the past twos are ones, and they can make a prediction. So the next one I'm gonna do 3. So the computer gonna choose 1. And then if I do 3, and then basically I lose. All right, but previously I keep doing 1, that I'm not really following the pattern. So that's why it doesn't, show the results. All right, but anyway, so but then this part, to really finish the game, okay, so we don't really need to provide any of this, okay, because this one should be coming from the history data, right? So that's why right here, we need to start to be able to learn all of this, and then to form the model in the runtime. So that's why we always need to constantly updating the model and updating the data set, and then retrain the model, right? So from here, we need to make some modifications. All right, so let's probably move this one also under here, because if you don't have enough data, it doesn't make sense to retrain the model. Okay, just do the random. But then right before you do the input and output data, I think we need to add a new record there, right? So for the input data, okay, at this point we should have some new history. So we should always grab the latest one, and then put that into the choices. All right, so that means I actually need the last 3 records. Okay. So I think I need to do this, right? And then the output data, we'll need to use the latest one. Okay. So here, just to clarify, okay, the code looks very hard to read, but the idea is very simple. Okay, so once you see 3 games, then you should be able to form 1 row of the data set. And then the input data will be the past 2, so it's 1, 1, and the next one will be 3. And then once you see the fourth one, then you're gonna slide to the right and use this 3 data to form the data set. So it's 1, 3, and then 1. Okay, and the next one will be 3, 1, 1. So that's why you see 3, 1 at the input data, and another one at output data. Okay, so that's how it works. Now, with that, I think this code should be right. But in this case, I think we need more than 2 records in order to run this kind of prediction. All right, so once we have more than 2, always computer gonna look at all the past history and then update the data set, retrain the model, and then make a prediction. Okay, so yeah, I think that's pretty much it. Okay, so I'm gonna delete this data here. All right, and then let me also print more things just to make sure it actually works, right? So let me print like input data. As well as output data. All right, so that way you can see we're supposed to see the input and output data grow step by step. Okay. All right, so let's actually make a final test. All right. So first of all, let me see if this input and output data actually is getting there correctly. So I'm just gonna do the same pattern. So 1, 1, 3. Okay, and is that printing? So we do 1. Oh wait, something's wrong. So line number 22. Oh, we only have 1 class. Okay, so this complaining is that yeah, because we want to do the classification, and right now they're only just 1 type. So to make that maybe what, I would just do some randoms in the beginning. Okay, I don't think this is going to matter too much. Okay, so I'll do an initial prediction. That way we can avoid the situation. Yeah, this error, because when you try to do classification, you need to make sure the target data, sorry, the output data have more than one type. If you only have one type, there's nothing to classify, so you only have one type. That's what the error is about, right? So that I will just set an initial value here so that we can have something to get started in the beginning. Okay, let me try to run this again. That way, in the very first one, I'm going to start record the data, right? So I'll do 1. Wait, why it's not printing? Oh, right here. Okay, so I see. And then 3. I do 1. All right, so from here, as you can see, the input and output data. Okay, so this is the dummy data I provided. Okay, but this 1 is the latest one we just inputted there. Okay, sorry, from the first one. Okay, and then the 3 is also the latest one. All right, so if I keep doing 1, 1, 3, as you can see, the data get longer and longer, and it started capturing all this record we've been waiting for. Okay, so this means 1, 1, 3, and this one is 1, 3, 1, and last one is 3, 1, and 1. All right, so but anyway, so if I keep doing this thing here, 1, 1, 3, and what we should be able to see is that this pattern started repeated more and more often, and then it shows more and more in the output data. And later on, once you do this, every pattern is going to capture it. So I should see this result to be mostly getting loose and then eventually always loose. Okay, let's see if that happens. So 1, 1, 3, 1, 1, 3. As you can see, the pattern pick up this one pretty quickly. So it's always loose. Okay, just watch the results. So if I do 1, 1, 3, 1, 1, 3, 1, 3. And obviously, the more you play, the more you repeat the pattern, the model gonna put more weight on that. So it always predict correctly. Okay, see this result, I'm basically just keep losing. Okay. But if now I start to change my pattern, so I start to do okay. So you know how I play. I'm gonna change it. I'm gonna do 2 2 3 1. Okay, let's do 2 3 1. So once I change the pattern, and the result going to be different. Okay, because the machine learning doesn't know how to predict this. But if I keep doing the same thing, 2 3 1, 2 3 1, 2 3 1, 2 3 1. Again, it started to get that pattern and then start to make the right predictions. All right, so that's basically how you can integrate this classification machine learning into this little example. Yeah, again, the goal is to convince you that to show you how the classification actually works. Remember, this is not regression. We just want to try to predict a choice among 1, 2, 3, and yeah, but you can see this one does work very well if you actually keep the same pattern. The model is SVM. We kind of briefly talk about that one. It's a very popular model. Is sklearn, always one of your top choices. You can try to run a machine learning on classification. All right, so that's pretty much what we are expecting from the assignment. All right, any questions? Right, and yeah, Kyla, I saw the error. Yeah, that one also very common. Yeah, it basically means that when you are trying to run a prediction, you got to make sure the format is right. Okay, so this part, because look at your input data. Input data is a list of a list, and every item in that list has 2 items. So you need to make sure exactly the same format. Okay, because however you train the model, when you make a prediction, you should supply the same kind of input data. Yeah. But for Python, the error messages are pretty good. Okay, normally they give you the clear issues. Okay, so like the one I had earlier, this one here, just try to read it and Google it. Normally you can find the answer pretty easily. All right. Any questions? Has anyone done a different algorithm for this rock, paper, scissors? Danny, has you finished the summit yet?
Yeah, I already submitted mine. I used something similar to SVM, and then there was another one I think called like Cluster Forest or
Okay.
something.
Right. Yeah, there is also something called random forest. That's also
Yeah.
yeah. Yeah, random forest is another one that's being used really often. Normally also very powerful. Yeah. All right. If you guys don't have questions, I'm gonna move on to the next topic. Okay. So, but this example, definitely try it. Okay. It's a lot of fun. And if you understand how this one works, you can see how this one being applied in practice. I don't want you to just see that, oh, machine learning just give you a bunch of data and make a prediction. That's it. You can very easily integrate it into a certain system like this. Okay, so in reality, Amazon make the recommendation algorithms, Netflix, they have the recommendation stuff, very similar to this one. As you keep watching, they collect your history and then they updating their model to make a better prediction for you. Okay, same idea. All right, sounds good. Now I'm gonna move on to the next topic. Okay, so I will stop recording so I can have a separate recording file.